And now our last speaker here on Platform 2. John Willis has over 40 years of IT management experience, currently researching DevOps, DevSecOps, IT risk, modern governance, and audit compliance, and how it all integrates with Gen AI. He has held key roles at Docker Inc., Socketplane, and Stratius, Opscode, and founded Gulf Breeze Software, an award-winning IBM business partner. And Stratius. Better?
Yeah.
An accomplished author, Willis has written 6 IBM Red Books and 4 books for IT Revolution, with his latest work focused on the operational history of generative AI. The title of his talk, Anatomy of an LLM. Please give a warm welcome to John Willis.
Thank you, sir. All right. Oh, uh-oh. AV problems already. Okay. I thought we had checked this out. Hey, there's my, now you have the, all right, we had it working, so, all right. I don't know what changed since the last time we checked it out, but I think it's the, again, where you have to change the primary screen. Oh. Okay. Well, I mean, we tested this out, and it seemed to work, but...
So, yeah, I cannot click on anything.
All right.
It's no cursor, no cursor.
Yeah,
I think the computer is plugging now.
no, it's not the computer. Oh, hold off on that one, if you don't mind. Yeah, because now it's working. Yes. So when you put that in, it stopped working. Because when we tested it, it was working with this one.
That's fine. Maybe sorting of the bookings. Yeah.
Okay, but now we don't have the, oh, come on, man. I don't even have that. All right.
Can you mirror the screen?
Yeah. Where's the mirror? I can't remember. Yeah. All right. Thank you. Okay. Here you go. Thank you. Wow, there's a few more people here. So I was saying, like, what the hell are you doing here at 4:55 on a Friday? You're either really boring like me, didn't mean to insult you, or you're a real geek, or something else. I don't know. All right, let's have fun, though. Anybody like having fun? Nobody? All right, there we go. A couple of folk, yeah. So this is actually like a 4-hour workshop, and I'll give you the sort of backstory of why I'm trying to do this. I'm really concerned. I am a big fan of generative AI. I think it's awesome. I've coded more in the last year and a half than I've coded in 10 years. I'm solving problems that used to bore the crap out of me. Now I love solving hard problems. But I'm scared for the large banks and the large insurance companies in that there's a technical debt tsunami coming, and that we have to educate the people who protect the fort really fast, because we're not getting involved in the discussions of all this technology that's coming into our world. In fact, I would argue we're not even knowing what question to ask yet. So what I started with, instead of trying to explain that problem, I figured let's try to educate. We run DevOps hackathons for generative AI. And so this is really a small version of a 4-hour or full day. In fact, me and Patrick DeBar are doing a longer version at DevOps Days Amsterdam next month. So if you know who Patrick is, he's the godfather. I'm the consigliere of DevOps. So this is the agenda. I'm not really going to do the workshop labs. We wouldn't have time. But I will give you a link to a place where we've been keeping all of our hackathons and workshop stuff, so you can sort of go out there, and it's all, if you want to change something, you find a bug, don't yell at me. Just put in a pull request. So just who am I really quick? Done a lot of stuff. I've been spanning this nonsense for 5 decades. That gentleman this morning really nailed it well about how we do some things really terrible, right? So that's been the story of my life. I've written a lot of books. I've done a lot of startups, done 10+ startups, probably 14 books. If you're familiar with DevOps, I co-authored the DevOps Handbook. I did a couple other projects. I spent a lot of time in sort of a DevSecOps, which we called automated governance, or DevOps automated governance. That actually eventually turned into another book with 8 other authors. I'm a big fan of Dr. Deming. I'm actually going to use some of my book to show the demos of how this concept of an anatomy of an LLM is. I use my book, so I'm truly trying to get you to buy my book. So, ton of startups. Probably the most notable was I did a startup that in 3 months I sold it to Docker, right? And we were like the 31st and 32nd people in the startup. I was 9th person in at Chef. I sold the company to Dell. So I've done a fair amount of like crazy stuff. Sort of a jack of all trades, master of none. I do have today, my day job is what I call a fraction. I'm tired of startups. They definitely shorten your life. But I've decided that in most startups I really have been the evangelist role. Like the person that on Monday can give a presentation, executives Tuesday can build some scaffolding, on Wednesday do a demo, on Thursday do a training class, on Friday start all over again, right? So I decided, like, why don't I just sort of end my career, knock on wood, as being a fractional evangelist for other startups. And so MongoDB has a vector database that most people don't know. The CMO is a good friend of mine. I called him up, do you know that none of your customers know that you have a vector database? And so he hired me on the spot. Hedgehog is, let me just say this, they're trying to run basically Kubernetes, K3S on SmartNICs that could be an immersified tool to manage complex GPU configurations. If that makes sense, disregard everything I said. If that fascinates you, go take a look at Hedgehog. And Acorn are the Mantra folk that have pivoted to create an interesting thing called GPT script. So that's all I'm going to say about that. And Rise is an evaluation tool. I do use some of that. There's my book. I said, if you know anything or interesting Deming or organizational design or where lean came from, this is the person that's pretty much drove that topic. Anything you think is interesting about lean or even DevOps, really, you can trace back to this incredible human that I spent 10 years trying to write a book about. I do have 2 newsletters. One is about my sort of organizational design, Deming. If you saw Dan Nort's presentation this morning, like he talked about some of this, just touched on the Deming in terms of organizational design. And then I'm trying to sort of build up, I'm writing, this might be my last book, is the history of generative AI. So I like to tell storytelling stories. So teach you some really deep technology, but then also give like human stories. And so I'm having a lot of fun, about a third way done, hopefully done end of the year. Basics. My book is primarily focused on the arc of neural networks, is really symbolic and sub-symbolic in terms of like AI. Your sort of symbolic is your expert systems. I'm not going to go too far into this. And there's an interesting arc of what's happened over the years. Like there's always been, until like 2012, the arcs have always been symbolic and sub-symbolic. So there's sort of a drift that goes up, and then they sort of crash into what they call AI winters, and then they go back up again. And then right about 2012, they cross over, right? And that sort of happens at the attention is all you need paper by Google, which is the T in GPT, transformers. And it all started with McCullough and Pitts, who basically is probably more information than you need to know, but they were trying to map how the brain works in a computer, in computers before there really were computers. Like that's another really, like Turing wrote a computerized chess program to beat one of his friends, and there was no computer. These are really smart people. I think it's a little interesting to know what a neural network looks like. These are called deep neural networks. That means there's more than 3. There's sort of an external, there's input, output layers, and then hidden is where all this sort of magic happens, right? This is a whole, like, master's degree. I'll show you sort of the hello world of this. I think, IBM did a pretty good job of sort of documenting the basics at a high level. Probably the hello world of neural networks is by a guy named Jan LeCun, who when he was at Bell Labs, and everything happens from Bell Labs. Just seems Bell Labs is like part of a lot of stories. They needed the U.S. Post Office and NCR. Post Office needed zip codes to recognize handwritten zip codes. So they got 70,000 handwritten from students, and they built the first basically neural network, not a deep neural, so it's 3 layers, to basically try to recognize, is this an 8, is this a 7? It's all probabilistic, right? And not to go too far into it. And if I went too far into it, I'd be lying to you because I wouldn't know. But this is what's interesting too, though. All right, so once you sort of, you create your version of a neural network, right? Like basically it's a vectored, it's vectorized, but it's ultimately called embeddings, right? And all right, this is the quickest thing I can do here is, most of you, if you've played AI, you see these like crazy lists of floating point numbers, right? And they're embeddings. What they really represent is a highly dimensional vector space. So if you think about trying to put the word dog and cat on a 2-dimensional vector, right? Like you would have basically, this would be 5.8 or 32, and that'd be the point where dog is, and this is where cat is, like another 2 numbers. If you go 3-dimensional, you'd have 3 numbers. If you're using OpenAI GPT, GPT 3, 5, or 4, by default, it's 1,536 dimensions. So that's why you see, I wouldn't recommend this, but if you counted the embeddings that you see, you'd see 1,536 of them, right? And one last thing, which is, and again, this is the simplest way to describe this is what I'm trying to do in my book, is basically it uses cosine similarity, and it's not the only way, to tell the difference. So when it's predicting the next word, the next 10 words, the next sentence, the cluster, what they call the chunk of the paragraph, it's all starting with like trigonometry, like where it is and what's the location. And that's the start. And it gets way more complicated. If you want to know the real complexity, read the Attention Is All You Need paper by Google, and it will tell you literally what do you ever want to know about the math behind it. But what's interesting, there was a team that did a hackathon. They built this thing where they built a community-based command, like a history command, but they put their own sort of abstraction around it. And so what they were running it is in their organization, they were running it like they seeded it with a bunch of, sort of Linux commands, OS commands, any kind of command that you run on a terminal. And they seeded it with a bunch of well-known, but then they kept populating the vector database with new commands. And so ultimately what happened was they built this system where you could say, what was the command that I ran last week to reload the SQL database for this, and it'll do a natural language as opposed to scrolling through and grepping the history command. It would literally come back and tell you, and then maybe even add in some context of the command and improvements. But what was really fascinating is when you sort of visualize the vectors, you start seeing, and I'll show some more examples of this later, you start seeing some really interesting patterns from the data. I think this is fascinating. So when they visualized all the commands, and this was just a small prototype, but you start seeing clusters. So imagine you've got a group of 100 developers and sysadmins, and you can start visualizing clusters. Now you might start seeing, like, and this isn't a good ground, but you might see like 3 commands that are always run together. And why aren't they just running this command down here? Because that does what those, like you can start getting some insight, even though a human can never understand, sort of like a GPT-4o model. And I'm not recommending you visualize that. There's some people do. But if you're building your own corpus of data, you can basically, and I'll show you later, I've done with my book, you can see things that would be impossible to see by a human by just like lassoing and spreading out this vectorized data. It's a byproduct of something I've learned that's incredibly interesting. The other thing, remember I said earlier, like sort of my person on a mission is that we need to educate the people who do protect the fort, the infrastructure and operations people, right? Like we're getting, and I have a lot of friends. I work a lot with Gene Kim's organization, IT Revolution, and I get to query a lot of these leaders who are usually one away from the CIO or chief of staff for a CIO, and I'm constantly in a sort of circle that I can ask. And the thing that's happening a lot now is questions from the CIO are coming to like Courtney Kisser now at Starbucks, as an example, not this is an exact story, but like what HR wants to bring in this new chatbot or Copilot, and it's going to do this and this. And the question is, like, unlike anything else we've been involved in the past, we're not able to ask the questions of those people. We can't ask, like, if we don't know how to ask the questions. And so what I started thinking about was, when I got into distributed systems, I was like a mainframe person and did proprietary IBM stuff and then got thrown into the distributed world really quick. And the thing that sort of helped me really was the LAMP stack. The LAMP stack was a sort of lighthouse for me. Oh, I get what you're doing. That's Linux, that's Apache. And I thought about, like, I don't want this to be a plaque in my name or anything. By the way, Cam's was mine. But the subclass. I figured, like, how do we get us all on the page? If you're on a page, you're an AI person, you already know this. Okay, Bob's your uncle. But for the people that I'm trying to educate is, if we could at least talk around some sort of simplistic taxonomy, like what is a LAMP stack? So I came up with a language model orchestration. We'll go through these quickly. Observability, by the way, observability means something different than the sort of classic modern observability that's been sort of invented by Honeycomb and others. We'll talk about that. RAG is sort of really getting a lot of oxygen now. This is where you create your own vector database, your own corpus data. And then model providers, that's going to be a thing, right? Like, I'm going to have to create supply chains for this stuff. I can't just let a team over there grab some embedding, this model, do this, put out this thing. Oh, that sounds like we were doing 25 years ago with code, right? Like, we got to think this through, right? And then the whole autonomous agent thing. Ray Myers, who spoke, I think yesterday, like, go back and watch. He's really, like, leading the charge, especially for, like, software engineering, autonomous agent. Like, I think he's nailing it. Ray, you in here? All right, no worries. And so just quickly, orchestrations, you probably heard of LangChain, Llama Index. They sort of do everything for you. A good friend of mine says that they're kind of like, not exactly like the Vagrant, like how we got started in Cloud Vagrant, like, oh, well, now I can use Cloud because I got Vagrant. And so LangChain might be that thing, or it might be here to stay, I don't know. But it's a great abstraction for getting started. Because it does a whole bunch of stuff under the covers that would be way more complicated to do. And Llama Index following, and there's a couple other. And Stanford's got a really interesting one called DSPY. Again, look them up. But one of the things we did, we ran like about a year and a half ago, we ran the first generative AI DevOps hackathon. And it was really more of a thought leadership thing. I brought in Patrick. We brought in a lot of the people that help create DevOps. And we started thinking about what the world might look like if this thing went all the way through and it was running in a large bank. And we started thinking about, like, there's going to be more than one LLM, right? And there's already the idea of a mixture of experts. But like, from our place of people who want to protect the brand, protect adversaries, adhere to audits, like all these things that sysadmins and DevOps people, and we need to have the concepts of red teaming. And there's already good papers on red teaming, governance. We need to make sure that the data that doesn't get out is calibrated and checked before it gets out. I think an Al Gore trading, like a sort of Goldman Sachs, right? If they were creating their own co-pilot for coding high-frequency trading or Al Gore trading, that might be very helpful internally, but you'd want to make sure that there's some gate somewhere at the end of that so that, like, it would never answer this question behind this border. Like, it would never, like, you could, and so the thing is, you put in questions that should never have answers to. What is the algorithm code to do this, for funds that do this, and like, the answer should be not found. Or a famous athlete's contract. It's sort of a Nike or something like that, right? So, all right, and then finally, the second to last is the idea of this observability I promised to talk about. So when we think about observability in IT, we think about latency, performance, we think about OTel, right, that kind of stuff, right? But like and unfortunately, there's been a conflation of the word, can't bring it back, too late now. A lot of the ML ops tools that have been around forever are calling themselves observability. So you have sort of what I'm calling a postmodern observability, and this is about, and I have some slides on this in a second, it's about correctness, relevance, hallucination management. So when everybody says, oh, I can't use that because it hallucinates or it makes up things up, it doesn't make anything up. It gives you the answer that it thinks you were supposed to get. It's a probabilistic engine. And the way you sort of tame that monster is really a combination, one of the ways is through RAGs and evaluations. So you can baseline, like what is the relevance, correctness, and hallucination at a percentage point, And as I update the database, am I staying steady, going up, or going down? Going down for relevance correctness could be a bad thing. And there's a couple of tools out there. LangChain actually has a pretty good implementation as part of their system called LangSmith. And so, yeah, as I was saying earlier, like when we talk about observability, it's really called evaluations. What we're really talking about is managing hallucinations, like actually using sort of LLMs as a judge to basically say, you know, like that was a hallucination. And then correctness, relevance, bias, toxicity, drift. So these are all things that like you're going to have to think about in a corporation. And here's the thing. If you're building a Copilot or LLM that's going to tell people where to find the best place to eat lunch at corporate headquarters, who cares? Load in a PDF with all that stuff in there and just, as we say, Bob's your uncle, right? But if, for example, a client I'm working with now are trying to build multi-language LLMs for people who climb up on electrical poles, and when they cross the wrong wire, they die, like then I'm going to want to do a lot of stuff here, and I want to do some other stuff in regs, because I want to make sure that, and then there's a longer conversation of like, it's never going to give you the answer, but it's going to actually find you very quick the system of record answer. But I still want that to be really high, you know, sort of high efficacy, high accuracy. So and that, you know, and that's going to be our job. We're going to have to really, again, if you're sort of like aligned with the idea of people who protect large banks and protect insurance companies, like these are things we need to worry about. And we need to tell the CIO that we're in. And this is just an example of like one of the tools, an open source tool by Arise. See, it'll tell you like the hallucination, it'll tell you the percentage correctness. And so I used my book. I took a PDF of my book, or took the source code of my book to learn all this stuff. And I used a lot of it in my workshops. And so I just ask questions, and it tells me, not only will it tell me what it thinks is a hallucination, so it's actually like another bunch of humans reading this and saying, oh, you know, you screwed up. You didn't explain it that well. And like a lot of these tools will give you detailed explanations, which is really cool. And some of them are actually not hallucinations. It's somebody is thinking, or an LLM, I didn't get into mental models, but an LLM is really just a non-human mental model, if that makes sense to you. And basically, it's telling you what it thinks. And some of those might be, no, I didn't need to answer that. And then there's vector databases. Just to be transparent, MongoDB Atlas Vector Search is one of my clients, but there's a ton of them out there. It really is actually, sort of the other dirty little secret is the technology used by most of these, not all of them, is basically what's called HNSW. It's part of Lucene. Almost all the PG vector, all those, they actually use Lucene. And they just turn. In fact, there was a story of a vendor that was asked at the booth, how come you don't have a vector database? And they're like, oh, we haven't got around to it. Like, you just got to turn this flag on in Lucene, and it works, right? So, and the HNSW, it's a graph on top of a vector, basically, to keep it simple. Again, the point of this presentation with 25 minutes left is not to basically go into detail all this stuff, to pique your interest, to know where to look. And you know, somehow through the navigation of this place, you'll get the deck. This is a really important slide when you think about RAG, you know, vector databases. And not because they're my client, but I do think the person who built MongoDB's document, LLM-based, you know, sort of chatbot documentation, it's one of the better ones out there. And they have like 2 or 3 blogs on how they built it. It was actually based on another person's, what they called naive RAG. But like, if you think, and I won't go through all these things, but it's a lot of work goes. If I need high consequence answers, if I'm not just giving you recommendations on where to go to headquarters, and either it will destroy the brand if the wrong answer gets out, or somebody will die because they crossed the wrong wires, then I need to do all these things. And there's a great article, we'll point to the original article, but things like red teaming, basically embedding optimization, I'll show some of that. Summaries in what they call chunking, re-ranking, end-to-end evaluation, literally building supply chain around the data. Really, really, one of the best articles sort of end-to-end on how to build an industrial RAG. And then, so if you're not familiar with Hugging Face, so one of the things I've done in the Hugging Face implementation is I've loaded my book as a Hugging, so the first third of my book, right? So, so I use that, and then I use examples in the workshop where you can load that in, and you can do a fair amount of cool stuff with with that. But you can use, like, there's examples of restaurant data, Airbnb. I mean, it's just Hugging Face is like the GitHub for data, for embedding data in models and stuff like that. So, so actually, let me show you one of the. Oh, we had to close that screen because we had all that problem. So let's do this. Oh, here it is. So I already ran this because it's kind of hot. But when you bring it up, what it does is, I'll just run, this is one of the notebooks in the workshop, somewhere here. So Copilot can have me have more fun at code. It hasn't made me a better coder. So I'll just be honest. I am as good a coder now as I was 40 years ago. So now it's loading. So what happened is it took the first third of my book from Hugging Face, which is out there, and then I run this. And then what I'll do then is, so here's the thing, when I talk about high performance state answers, like I need to work with my data. This is a data engineering problem. Like, don't be fooled into thinking you could just go into Claude and put your PDF in and it'll answer all the world's questions, right? It's better than not putting in your own data in the context, but it can still be very dangerous. And so, like, the things that you start working on in the the longer workshop is, first you start off with this idea of chunking. And that's basically how you're chunking the different sort of, we'll just call them paragraphs for now, of data. And it makes a big difference because you're taking your data and you're sort of breaking it out into locations and clusters where the vector and embeddings are going to point to. I know it's a mouthful, right? And so there's a bunch of stuff like overlap. Do I want a sentence to be broken up in the middle? Do I want a paragraph? And there's all sorts of really cool techniques built in for that. But then there's a lot of other stuff, like maybe at the end of the day, Markdown's a better way to build it in. Maybe but by the way, no one solution fits all data. It's the data that drives. And that's the biggest thing I do in my workshop, is you get to start testing the different, and just in this example here, when I chunk it at, let's go ahead and run this. This is at the first third of my book. I chunk it at 400, I have overlap, I'm just gonna get 10. And you'll see here in a second, chunk number. Why is the cosine similarity not coming out? It's showing me the chunks, but what I'm not finding right now is it should be showing me the cosine similarity. That's the other thing about this code. Like, literally if it breaks, wait an hour and it'll work again. I got to put in a query, you idiot. Okay. Let's say Toyota. That's why I had no cosine similarity. All right, so now we'll run that here. And the whole point is, so it's saying that the probability based on a cosine similarity, so how that vector and how this is vectored up, using the transformers and all that stuff. I know it's a mouthful. It's saying that chunk of data is the most likely, and it's 57% or 58% chance that that's what I'm looking for. But watch what happens when I change this to 300. It goes up almost 10%. That's why I'm saying the data is really important. One of the things I started realizing at some point, so it's gone up to 63%. So this is the thing, it was just like part of the data engineering. And there's sort of another thing that you need to start working with, which is which embedding models work better for your data. Small language model, embeddings, large models. There's no one right answer. Your data is going to determine this. Like, I'll read a blog article say, like, it's chunk at 400. And again, chunking is like taking your data, clustering it somewhere, creating a vector definitions to describe how to get there. And again, the format that you use to build this is very important for high consequence answers. All right, so let's go back to my presentation. Why am I not? Okay. So this, and this is really interesting too. So Mary was talking about earlier about how there's a lot of tools now. This one's called Nomic, but there's a lot of these tools now that will sort of visualize vectors or embeddings. And Mary told you earlier about seeing the command cluster, or I did this in my book. And I was at one of the hackathons when Nomic was one of the sponsors. I figured, all right, I was running the hackathon. And I sort of took my book in there, and then this idea of lassoing the clusters. So I lassoed Toyota, which is a big part, that if you don't know the Deming story, like he's probably signally responsible for the sort of the miracle in Japan, which then creates Toyota Production System, which creates Lean and blah, blah, blah. So I look, and there's sort of three different clusters of Toyota. One is sort of modern, one is old. But then all of a sudden there's a yellow dot, and I look down, and yellow is medicine. And there is nothing in my book that ties Toyota medicine. So interesting. So by the way, this is where you get to see where hallucinations can happen. So I do a little research, and I find out that in some of the early history of Toyota, they were a loom company before they became a car company. And some of the wording that I used in my book conflated loom terminology to healthcare. So this is really interesting. If you're writing something, you're writing technical doc. I actually used a tool like this to look at John Allspar's master's thesis. And it actually starts giving you sort of clustering information at a scale where you can start seeing really interesting stuff. And now my next book, as soon as I'm done with the first draft, so I did 8 revisions on my Deming book, right? Because I figured I wasn't in a race. I just kept, every time somebody gave me really good advice, I'm like, let's do it one more time. Let's do it one more time. And this time, I'm going to start with a non-human. Because I just realized the power of being able to look at the cluster, because think about like how we think about mental models. An LLM is just a non-human mental model. It's not, no human is correct about what, if we all saw something happen over here and we all broke out and had to explain it, what is it, 70, 80 people in here? We'd have 80 different descriptions of what happened. Well, LLMs are in some ways not that much different there. So like you could use an LLM to sort of evaluate your sort of what you're writing, what you're saying, how people are perceiving it. Did you overload terms? It's fascinating. And then here's the, this is the one the stuff that breaks, be prepared that like stuff that works for like 4 months straight, 15 minutes before you run your presentation, it breaks again. And like, again, in an hour from now, it'll work. But this is one I wanted to show. So one of the other things is really cool. I have this out in the demo thing, and I'll just either wait till it gets fixed or fix it myself. But you can use the different embedding models. Because not only you want to work with the different chunkings and the style of what you want to do for the data, then you want to start playing with what kind of embeddings work best. So if I was able to run this, that same thing, if I used, it's the Beijing AI Institute, which is a very powerful, and there's some better ones now, but it would have went up to like 70 and 80% for the Toyota. So again, this is part of the data engine. This is not really an AI thing. If you're a DevOps or you manage systems or you sort of protect the fort, it's just another variant of data ops, right? It's that, it sounds more exotic, but it's a data ops problem. Because it's all about the data, right? Like this, none of this stuff works without the data. And this is the thing I found. This is sort of like like my proven of the thesis was I took my book and I took all the numbers that I could get from evaluations, from similarity scores, and I did like 8 different examples of how I was going to do this. And one was I put the full book in, and overall, and by the end, if you look at the end there, I put the human evaluation on it, which it came from no software. So I sort of all right, precision was 25, correctness 67, hallucinations were 33%. That was probably not a good one. If I did chunking, the numbers went up, correctness was high, just a PDF. But PDF part 1 chunking, so maybe I want to break it up. In fact, what I would have done is maybe do it by chapter. And here's the thing, it wasn't, there was one that had a higher number than the one there. But one of the things, the human part of it was, even though the PDF part 1 had better numbers from what's called an NDCG, which is just another correctness score, at the end, when I looked at it from a human perspective, the best answer was actually the PDF part 1. So again, it's not all about the data. There's still a human in the middle. But there is a lot of work that goes into, and for my book, who cared, right? I do care. But at the end of the day, like nobody's going to die if they misinterpret my book, right? Or your brand is not going to get a $5 billion market cap loss because something really terrible went out on the wire. But if it's real high concentration, that's the last point where like I was able to say that might have been the highest numbers. So again, this has sort of been interesting. I spend more time on this in the workshop. And then there's the model providers. I sort of conflate the model providers and models just because I think that's where we're all ending up, right? Sort of Microsoft is OpenAI, Google is Gemini. Amazon can be anything, but they really sort of seem to be investing heavily in Claude, or Anthropic's Claude, and you got Meta with Llama. And then what's really interesting is the small language models. And this is really interesting for edge-based computing, right? Again, like you can get high performance for a very tight corpus of data for lower costs. So not everything has to be GPT-4o, right? So again, it just depends on that process of data engineering or data ops to figure out what's the best way. Because you might get really high, if it's a very sort of specific, like the sort of Goldman Sachs, and this is not a real example, the Goldman Sachs high frequency or algo trading might fit better as a small language model. Now you do have a risk then is somebody could take a brick, walk out the door with it, but that's another. So the last thing I want to do is like with the 10 minutes or so I have is really tie this into why I'm doing this training, and I'm not really doing it to make money. I don't mind if somebody pays me, but I really think I had a passion about DevOps. I followed my passion. I was the only American at the first DevOps Day. I ran the first DevOps Day in Mountain View at LinkedIn. I sort of started, me and Patrick DeBar kind of drove and started, but shoulder of giants, maybe millions of people helped create this thing. But I did it out of passion. I didn't do it. In fact, I thought I was ready to retire when I started DevOps. Like, I'm pretty old. But I've been sort of dealing with this for 5 decades of this idea that we have a promise of a new technology, we have a delivery that's short, and there's always a technical debt. And then so in the 1990s, it was something called automated console operation. In the 2000s, probably most people in the room started getting interested in there. We had like CF Engine, Puppet Chef, mutates into Ansible. I would say Ansible is putting Luke Kanice and Mike DeHaan in the same room. That's how you get Ansible. And nobody laughs, so it doesn't make sense. In 2010, I sold the company to Docker. I said it earlier. I actually was the 7th person in at Chef, and I was basically the 30th person in at Docker. So I got to see both of those waves from the podium. Composable infrastructure, Docker, platforms, Kubernetes. And then now we're in the same thing. So each time there's this delivery promise, there's what we deliver, and then it's actually, if we look at a large bank, large insurance company, that delta between those it's always swept under the floor. And they compound. So in the first generation, we have that, and we get the next generation. Because the truth of the matter is, on my cell phone, when I pull out my cell phone, and I want to go to Delta Airlines, I live outside of Atlanta, and I want to select a seat, I'm going from that cell phone to some sort of proxy, through some web service, through some legacy web service, to ultimately a mainframe. And that's the way it exists today. If you use American Express card, you're not only using a mainframe, well, the same thing with Delta, you're using a mainframe that is an IBM mainframe that is running an operating system that's been deprecated for 25 years. The reason I know that is I taught the team that developed that in Poughkeepsie when they were thinking they weren't going to have to support it anymore. And the reason I know that is my son was born 25 years ago. So here we are again. So actually, this was not Einstein. I love when people point out quotes that are not by the right people. It was actually a very interesting environmentalist, feminist, Rita Mae Brown, who actually said this, that insanity is doing. And so we're doing it again. We're proxying out all this stuff, thinking I'm seeing companies hire chief AI officers. That's not going to work out well. Because they don't care, they don't know. It's not even that they don't care. They don't know what GRC stands for, right? They don't, never been through an audit, or they will be through an audit, and the first 3 times they'll find out, they'll be running to the CIO and saying, what is these level 2 auditors talking about, right? Because you can go to jail. In a bank, you can go to jail. And it says that in your contract. And at a C level in a bank, you were warned about the consequences of not only doing something nefarious, but actually making a mistake. This is interesting. So I've been saying this. 9 minutes. Oh boy, I can do it. I've been saying like the whole shadow IT. Is anybody familiar with the idea of shadow IT? Like mostly driven by cloud, right? It was a nightmare. A friend of mine, says that 10 years it took us to clean that mess up. But if you think about a 100,000 person company, the net effect of that problem was about 5,000 people, right? Because like not everybody in the organization went ahead and, especially in the early days of Amazon Web Services, like it was only API. There wasn't even a console. Like so, like the other 95,000 people were not running Java code to call APIs to bring up EC2 instances, right? But look at the impact that it caused between brand recognition, auditing, control, waste, lots of stuff. Before I saw this by LinkedIn just recently, I was suggesting that with generative AI, it's not 5%, it's 75%. Because everybody in an organization now can run this technology. So the problem that you had with shadow IT is going to be at least 3 orders of magnitude more complex with shadow AI, which is becoming a new term, right? And again, and then like that's what LinkedIn like confirmed my sort of hypothesis is that 75% of knowledge workers around the world use generative AI. Okay, everybody kind of knew that. But what they found also in their survey is 78% are bringing their own AI, BYOAI, right? Now that, if I'm a CIO, I should be, or if I'm somebody who reports to CIO, or I'm going to be yelled at or responsible, or I'm going to have to spend 3 months with an auditor trying to explain this stuff, if you're not one of those people, God bless you. But like, if you are anybody in that realm, trust me, in a year from now, you're going to be cursing your brains out. You're going like, where's that guy that was on stage last year? Right? I need to talk to him. And it's too late. I'll be already retired. No, I'm kidding. But yeah, so, and then like, you heard the ad candidate thing. And the ad candidate thing is sort of a joke because like if you read the sort of details behind the sort of, so that if you don't know the story, some guy went into an ad candidate chatbot, asked if he can get a refund to go back to his mom's funeral, told him he can get a refund. Air Canada said, oh, no, that was a chatbot, And the lawsuit turned out, and like, this is a $5 billion market cap organization that had paid $1,200. Big deal. No, the big deal was they got to be the first use case of a generative AI, even though I'm pretty darn sure they were not running any generative AI. They were probably just running a JavaScript chatbot. Because when the thing happened, it was GPT-2, and very few on the planet knew what GPT was. But don't be these guys or these people. And so just the other day, right, and it turns scary. I think this AI stuff is here to stay. You ain't putting, it's do or die for most corporations. You're never going to convince the CIO or CEO that they're not going to use it. My only sort of plea is let's get the CIO on board that like don't think it needs to be proxy. And this just came out the other day from the Wiz. Like this is insane. So a Hugging Face, so Wiz basically, if you read the report, it's like brilliant. They literally created a poisoned embedding model purposely because they knew there was some escape code or sort of malicious code in Pickle. So they did that. They escaped out into that. Then they were able to escape to get into the Kubernetes that Hugging Face was running on Amazon, and they literally got access to a shared host on Amazon. And here's the point, right? That stuff's going to happen forever and ever. But the people, the inmates are running the asylum right now. Because the people that support these tools, that most of them don't know anything about security, vulnerabilities. They probably couldn't tell you what NIST is, right? And this is the problem, like, I'm very passionate about, like, getting ahead of the curve before the curve, like, runs us over. And then, so by the way, I think NIST is terrible right now. And if you went back like 2 years ago, I would tell you, don't read OWASP, just go to NIST, right? It's the opposite with LLMs, in my opinion. What NIST is putting out about AI, generative AI, is nonsense. And I'll debate that with anybody. They're really basically describing Google search, right? But OWASP is doing a phenomenal job here. The LLM top 10, brilliant. I mean, they are defining real problems that are arising. Poisoning of models, denial of service of models. The fact that somebody could literally pick up a model and walk out the building with your IP, right? There's a lot of really good information. In fact, there's a Google paper. So you had to go ahead and find my LinkedIn. If you didn't, you're not going to be able to get the answer to this question. But Google wrote a paper 10 years ago about the problems that banks are going to see. And I'll just give you a clue. Just do ML ops technical debt with Google. It's a brilliant paper. But they experienced it 10 years ago. When Docker came out, they were running containers for 10 years. So now, 10 years ago, there's a paper that describes the stuff we need to be aware of right now if we're managing and helping run banks and all that good stuff. And so the OWASP folk wrote a really good paper, and the thing I liked about it is they talked about not just the risks of using GenAI, but they balanced it with the risks of not using it, right? So I'm not standing up here not saying don't run generative AI. You have to. You have no choice. Just like you had to run cloud. A lot of people tried to ignore it. You couldn't. But there's things like competitive disadvantage, market perception, innovation strategization, operational efficiencies. That gentleman this morning, and I'm terrible at names. I can't remember my kid's name, let alone somebody I saw speak today. But the point is, there are going to be incredible operational efficiencies, and there already are with these technologies. In fact, if you think about I was trying to explain to people, sometimes nothing's new. I mean, Goldman Sachs 10 years ago probably had 8,000 day traders. They have probably 100 now. Why? Algorithmic trading. It's run by computers. So, again, I kind of believe the idea that, you better prepare for the future, because I think if you just write Java code all day long, you're going to have to sort of navigate what that means to your career. Because I think very much like the day traders, this technology will sort of probably take some of that path. But here's the thing about the sort of use case of the threats. The organizations that we rely on to tell us things don't even understand how to tell us what's happening. So your ovals, your sticks, your CVEs, all those things, if they mean anything to you, they're so behind right now, it's unbelievable. They're incredible. Here's a great malware. In fact, your JFrog people found that about a year ago. It was fascinating. So you know how LLMs hallucinate? Well, so does Copilot. So if you might have already seen this, right? So you'll sort of ask for some code, it'll have a library, and the library will not be a real library. So you run it, it says not found, and you find, it had a different learning, maybe it was renamed, whatever. You know what the adversaries are doing? They're finding those and putting their own code in it, so when you run it, they pwn you. Adversaries are incredibly creative people, and by the way, they have LLMs now to help them figure out how to be better at this. Phishing schemes, reverse engineering. Embeddings can be reverse engineered. So I'm working on a side project right now you can't just encrypt embeddings. That doesn't work. But you can do matrix multiplication, if you know what because that's basically what a NVIDIA card does. It really does one thing. It does matrix multiplication. And so literally, you can basically run a whole set of calculations against the matrix, which can't then be interpreted, but you can reverse engineer it by that number. Because an embedding in the wild can literally, with a GPU, you can reverse engineering to find the paragraph where that came from. And then sort of deep fakes, that's really the bottom of the list. I mean, it's bad and it's interesting, but there's a whole lot of subtle problems before you get to deep fakes. And then with the 28 seconds I have left, what do we do? I think one of the first things is maybe now's the time to deal with our legacy. The ability to convert stuff has never been better, so that technical debt compounding. Cigna, actually, I said this publicly, they make everybody take a training class where they have to checkbox that they took it. So now you can't do now, ask forgiveness later. You've been told and at this point, they know it's going to change, but they just have told somebody, and they went through, sort of like large companies, you got to take those annoying tests that you can't you have to go through at their pace because it doesn't let you go faster. A test about what you think today and change it in 6 months and a year from now is what people should and shouldn't be doing in the organization with generative AI right now. And then, again, you can't hey, well, I didn't know. No, you sign that and you're fired. The platform engineering is already, in fact, all the big providers are running some form of a platform, mostly Kubernetes, to OpenAI. They're running massive clusters of, of pods and stuff in Kubernetes. I mean, they're running all the backbone stuff y'all are running, basically. They don't know any better, any less, but they are. I think SRE is an incredible opportunity. I'm going to run over just by a minute. Don't think that because they hired a chief AI officer and you've got SRE over here, because the thing about SRE, if you read the original Google book on SRE, right? In fact, Tom Monicelli wrote a book before this. He was original SRE. And he talked about how Google was great at trying to say you only run 2 of everything, right? And that's how you manage scale. And that's kind of what SRE is about, right? If you sort of read the original manifesto of SRE, right? You come to us with a product, it's got to be in a certain format, and it's got to be these constraints. And so when we're talking about vector DeLorme, what I talked about, you get 1 or 2 orchestration engines. That's it. You get 2 RAGs. That's it. You get 2 orchestrate. And you got 2 choices if you want to run your own. 1 is you don't get SRE managed, or 2, you literally, you got to put up an incredible high-level use case, because that's how we win by scale. We create vendor relationships, again, MongoDB, they're my client. Let's say you choose MongoDB for your vector database. You create relationships with them. You scale with those. You know how to manage them. You become really good at troubleshooting them. And that's why you don't want 30 vector databases. You don't want every group to decide to build their own orchestration, all the things in a stack, right? Secure supply chain, I talked about this earlier. Not only we need to have supply chains of how we deliver these things into production. I mean, if you're on Jupyter Networks and testing stuff, fine. But once you're moving stuff into production, you want to manage this stuff the way we manage software, data ops, right? And then, then why not get ahead of the audit game? Start putting digitally signed attestations, immutable attestations, that's what that earlier book, Investors Unlimited, was about, in the pipelines. So auditors can look at it and say, if you heard of SigStar, put it in SigStar, and literally you can have, here, auditor, this is RSA encryption. If it's broke, we got way bigger problems. And then I don't have to have a ServiceNow record where I have to spend a month explaining what happened. Yeah, that's it. All right, thank you so much for sticking around here today, and I'll be around for a little bit. Any questions? And thanks.
John Willis, everybody. Thank you, John, for the talk.
Yeah, that was great.
We don't have time to get into the Q&A, but if folks have questions, can they catch you
Yeah,
after?
I'll stick around for a little bit.
Perfect, perfect.
If
We
you
have
much of
a
a